Good evening, everybody. So, in the morning lecture, we discussed about the boundary layer formation, thickness of the boundary layer, and various thickness related to the boundary layer. We discussed about it. At the end, I mentioned that the first problem in boundary layer is how to determine the thickness of the boundary layer. So, in this lecture, I work with you in discussing the problems related to the boundary layer thickness. Boundary layer thickness determination. That is the topic. So we already mentioned there are four things. One is nominal thickness. Nominal thickness, the velocity, free stream velocity is equal to 0.99 times the velocity. Then we call it as the boundary layer thickness. Then second, displacement thickness. This displacement thickness is delta star, which is equal to integral 0 to delta 1 minus small v by capital V into dy. Then third one is momentum thickness. And momentum thickness is theta, which is equal to 0 to delta. Then it is v by capital V into 1 minus small v by capital V dy. Then fourth one is the energy thickness. Is equal to delta double star is equal to integral 0 to delta. It is v by v capital V into 1 minus small v square by capital V square dy. So knowing this, let us take a problem in this and then the first problem I take it is find the displacement thickness. Delta star, then momentum thickness theta, and energy thickness delta double star. For the velocity distribution, u by capital U is equal to y by delta, where small u is the velocity at a distance y from the plate, and u is equal to capital U at y is equal to delta, where delta is boundary layer thickness. So this is the question. So the distribution given is u by capital U is equal to y by delta. It is nothing but v by capital V, the same order. Y is the distance measured from the boundary and delta is the thickness of the boundary layer. First, displacement thickness. So displacement thickness we already know that it is delta star, which is equal to integral 0 to delta 1 minus u by capital U into dy. That is whether it is small v by capital V or small u by capital U, both are same. So therefore, delta star is equal to integral 0 to delta 1 minus what is u by u? It is y by delta into dy, right? It is equal to, so integral 1 into dy is, this is 0 to delta dy minus y dy by delta. So what is the next question? It is, if I take it, it is dy means, dy is next thing is, it is y minus y dy means y square by 2 into delta, limits are 0 to delta. So it is delta minus delta square by 2 delta. So it is equal to delta, delta will cancel. So it will be delta minus delta by 2. So answer is delta by 2. This is the first thing. Second thing we will take it. Then second one is momentum thickness. This theta is equal to integral 0 to delta. It is u by capital U into 1 minus small u by capital U dy. So theta is equal to integral 0 to delta u by u is y by delta minus y by delta into dy. So it is y by delta into dy minus y square by delta square into dy. So if I integrate it, then actually y by dy and y square by 2 into delta minus here y cubed by 3 into delta square 0 to delta. So delta square by 2 delta, delta square by 2 delta minus this is delta cubed by 3 delta square. So it is delta by 2 here minus here delta by 3. So if delta by 2 and delta by 3, if I put it, it is going to be delta by 6. Therefore, theta is equal to delta by 6. This is second. And third one is basically the energy thickness. Energy thickness. Energy thickness is called as delta double star, and it is equal to integral 0 to delta u by capital U into 1 minus u square by capital U square into dy. So if I take it, then actually u by u is equal to y by delta. U by u is equal to y by delta. Therefore, integral 0 to delta y by delta into 1 minus y square by delta square into dy. In 0 to delta y by delta into dy minus y cubed by delta cubed into dy. So if I do it, y dy means y square by 2, y square by 2 into delta minus y to the power of 4 by 4 delta cube 0 to delta. So it is delta square by 2 delta minus delta to the power of 4 by 4 delta cube. So it is equal to delta by 2 minus delta by 4. So it should be equal to delta by. So delta star double star is equal to delta by 4. So this is another. So now I will do the second problem, because out of these two problems there is guarantee that one of the problems may come in the end exam. So the second one is again find delta star, theta and delta double star for the velocity distribution. u by capital U is equal to 2 into y by delta minus y by delta whole square. This is second. So how I will do? So let me go into straight away this displacement thickness. Displacement thickness delta star is equal to integral 0 to delta 1 minus u by u into dy. So therefore integral 0 to delta 1 minus 2 into y by delta basically minus y by delta whole square into dy. So integral 0 to delta 1 minus 2y by delta plus y square by delta square into dy into integral 0 to delta dy minus 2y dy by delta plus y square dy by delta square. It is equal to dy is y minus 2y dy means 2 into y square by 2 into delta, right, plus y cubed by 3 delta square 0 to delta. So if I put delta minus 2 delta square by 2 delta plus delta cubed by 3 delta square. So it is delta minus delta cancel 2 delta minus delta plus basically. So delta square delta it is delta by 3. Right. So the answer is finally delta star is equal to this will cancel. So delta by 3. So this is the equation for the displacement thickness. The second one is momentum thickness. Theta is equal to integral 0 to delta. It is u by capital U to 1 minus small u by u dy. So if I write it again for this, actually integral 0 to delta, what the equation is basically if I take it, what is u by u? 2y by delta minus y square by delta square into 1 minus 2y by delta plus y square by delta square into dy. This is the thing actually. So if I elaborate it now, if I take it, it is equal to 0 to delta. This term if I take it, it is to 2y by delta minus 4y square by delta square, right? And plus basically 2y cubed by delta cube, then minus y square by delta square plus 2y cubed by delta cubed, then minus y to the power of 4 by delta to the power of 4 into dy. So now if I do it integration, it is y dy. Y dy means 2 by delta into y square by 2. This is first term minus 4 by delta square into y square dy. This is 4 by delta square into y square dy means actually y cubed by basically it is y cubed by 3 plus 2 by delta cube into y cubed means y to the power of 4 by 4, right, minus y square by delta square means 1 by delta square into y cubed by 3, right, plus 2 by delta cube into y to the power of 4 by 4, right, minus 1 by delta to the power of 4 into delta to the power of 5 by 5. There. Now if I substitute it, 2 by delta into delta square by 2, first term, minus 4 by delta square into delta cubed by 3, plus 2 by delta cube into delta to the power of 4 by 4, minus 1 by delta square into delta cubed by 3, plus 2 by delta cube into delta to the power of 4 by 4, minus 1 by delta to the power of 4 into delta to the power of 5 by 5. So this is the whole story. So if you simplify all this, you will get actually 2 delta by 15. So this is theta. Then what is the third one actually? The energy thickness. Energy thickness. It is delta double star. It is equal to integral 0 to delta u by capital U into 1 minus u square by capital U square into dy. So then in that case, it is equal to integral basically you can write 2y by delta minus y square by delta square. This is 1 minus, then this is the equation is 2y by delta minus y square by delta square whole square into total dy 0 to delta. So 0 to delta, first one is 2y by delta minus y square by delta square into 1 minus 2y by delta square means it is 4y square by delta square plus y to the power of 4 by delta to the power of 4 minus 2 into 2y into y square by delta into delta square dy. So it is 0 to delta basically. If I take it 2y by delta minus y square by delta square into basically 1 minus 4y square by delta square minus y to the power of 4 by delta to the power of 4 plus basically 4y cubed by delta cube into dy. Now multiply it actually 0 to delta. If I multiply it, it is 2y by basically you take it 2y by delta minus y square by delta square 2y by delta second term it is minus 4 into 2 8y cubed by delta cube then plus 2 into y to the power of 2 into y to the power of 5 by delta square basically y to the power of 4 by delta to the power of 4. So delta to the power of 5, then this plus this minus this is also minus then this is 4 into 2 8 y to the power of 4 by delta to the power of 4. This is first minus this if you multiply y square by delta square then minus plus plus 4 into y to the power of 4 by delta to the power of 4 then minus minus plus y to the power of 6 by delta to the power of 6 minus 4y to the power of 5 by delta to the power of 5, all this multiplied by dy. So if I do it, it is 2y dy means 2 into y square by 2 into delta. This is first term minus 8 by delta cube into y to the power of 4 by 4. This is second term minus y to the power of 6 by 6 plus 8 by delta to the power of 4 into y to the power of 5 by 5. Next, then minus y cubed by delta square plus 4 by delta to the power of 4 into y to the power of 5 by 5 plus y to the power of 7 by 7 into delta to the power of 6 minus 4 by delta to the power of 5 into y to the power of 6 by 6. All this, now you substitute delta. If you substitute, this is here, if I take it delta square, delta will cancel, 2 will cancel actually. So then naturally the first one will be basically, if you simplify all this, you are going to get 22 by 105 into delta. This is delta star. So my request is kindly work out these two problems. And once you work out these two problems, then basically you can solve any equation, because we have already solved two distributions, which are the difficult distributions. So any problem you can really easily solve in this particular thing. So kindly note that again, the equations you have to first, what are the equations for this we need to understand. Once you understand the equations, you can find displacement thickness, momentum thickness, and energy thickness in the boundary layer. So this completes for us one particular question in the even examination point of view also. Here I will stop, and in the next lecture we go further next topic of the boundary layer theory. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.